Okay, so welcome to my dear student. So today I am going to give you a very basic idea about a reliability workbench tool called ISO graph. So this reliability engineering, that is my regular course in I used to take in training school, and there I used to teach this tool in details. But today I'm just going to show you a very basic reliability analysis using fault tree. So what is fault tree? This all details I am not how to find out the um, failure probability and all these things. Those are the part of probability and stochastic theory. So those I am not going to detail this all these things here. Basically, very recently I got one work from Harbin Electric Equipment Company. Uh, uh, to do a big system failure analysis. So I thought, why to not make one small introductory video about that. So I am taking one small example. Say this is one fault tree. Basically, we are going to find out the unavailability or the reliability of the water overflow indications. So those are depend on three events. So the circuit, the electronic behind it may fail, or the sensor may fail, or there will be no power. So it is given, we are assuming that all probability is given. So the sensor failure is 0.02, and the circuit failure may happen if the chip is failed or the indication, the warning lamp is burnt. Similarly, the voltage, the power cut can happen if there is no voltage in the network or the fuse in the system is burnt. So very quickly we are going to calculate this fault tree. Basically, this will give you an idea how to do the modeling and the calculations. Okay, so this is the reliability workbench. This is the, as I told, it's ISO graph. So this is the main window. Then as we are going to do fault tree analysis, you click here. So now this is the blank area where you need to design. So first, this is the top gate. So here we are going to uh, so this first you need to give the ID. So there here the water overflow failure analysis. Okay, so I am writing water overflow. Okay, now under this, if you see this, there are three event. Okay, one is uh, circuit failure, sensor failure, and the voltage failure. So I am adding, this is I will add one more here. So this is my, this name I give, this is the circuit failure. So this is my circuit failure. Okay, then I will give the sensor failure, sorry, then I will give the sensor failure. So this is my sensor failure. So sensor sensor failure. Okay, and next, this is my voltage failure. Voltage failure. Okay, now you see these are in OR. So okay, this is in OR. Now under the circuit failure, this may happen if chip failure or the warning lamp is burnt. Okay, so I will add here two events. Okay, so this will be, first event is chip failure, and the next event is lamp failure. Just I am just showing you this how to do. It's a very small example. Then this is AND gate actually. So change this gate to AND gate. Okay, and now the next one is here. Sorry. So this here I have to add two events. So you please add, and another one I am adding. So anyway, this will be again AND gate. If you see my logic, the diagram which I considered here, it is AND gate. So there is power cut or fuse blown. So this is for power cut, or this is my fuse burn. Okay. Now I need to give the all the probability. Okay, so that how to calculate the failure rate and all, it either it is given by the manufacturer, from the manufacturer data sheet you will get, or you can calculate by your own using some historical data. So those part that is also can be calculated. Here if you see, there are a lot of things. There's a this is a Weibull, and this is a Markov, uh, all these things, using this all these things you can predict it, but I am not going to tell this all, show you all these details. I will show you later. So now I am going to, here I am going to give some value. So the model type I am considering, it is mean time between the failure. So say this failure is uh, 0.02, and the repair time is, sensor repair time is say 5 days. Okay, now we need to do the define the unit. So you go to the project tab, and in general, this here you see this is the unspecified. So this failure rate you can give in year, and mean time to repair, it is in hours. Okay, so now the chip failure, similarly I am adding all these things. So chip failure per year may be 0.01, and the repair time is say 10 hours, something you give, whatever. Then the lamp failure you can define, this is per year say 0.002, and the repair time is 1 hour. Similarly for power cut, that is you can give, that is per year uh, say 0.04, and the time is 1 hour to restore the power back. Similarly fuse blown, that you can give, this is say zero point 0.1, and this is time is 0.2 hours. So now the model is ready, my small fault tree is ready. Okay, so now I have to set up the calculations. So in general tab, uh, you go to the calculations, and here you define the lifetime, say it's in 10 years. and the card set sorting method, it will give in terms of probability. Okay, then what are the things? Hmm, and you can customize the approximation method. So you can see the modularized sets here. So these are the all other so many settings are there that based on your requirement you can do it. Now hope this small fault tree is ready to run, and this is the button. If you click, it will do the analysis, and the analysis is complete. Now you can see all the result. This water overflow, failure, or the unavailability, it is seen. You can click here to see the result, the summary. Uh, Now you can see the unavailability is unavailability is 1.14 into 10 to the power minus 5, and the frequency is this much, and this is the unreliability. So all these things it has come. So I will, and here is the cut set for all the event. So this is a very simple way how to do the fault tree analysis. This is a very small system I have shown, but this can be applied in very critical system like uh, nuclear power generations, space applications, mainly in aircraft engineering, where the reliability is the most uh, concerned. So there you can apply. So just I have given one small idea how to use the tool to find out the reliability of a system using fault tree analysis. So thank you so much. Thanks for your patience.